Welcome to Get Your FRQ On. This question is from the 2001 exam. It's question 2, and it is calculator active. In the question stem, we are given a table of temperature values for water in a pond, taken every 3 days for 15 days. So there are 6 values in the table, the day number, and then the temperature of the water that was recorded that day. So part A of the question asks us to approximate W prime of 12, show the computations, and give units. W of T is just a function that represents the temperature of the water in the pond at a given time, and since all we know about W at this point is the values in the table, we'll use the values in the table to approximate W prime of 12. Now normally when we have a table of values and we are asked to approximate the value of a derivative based on the values in the table, you would be expected to write a difference quotient, so you'd have to show that focused on the value of t in question, in this case t equals 12. There's generally 3 different ways that you can do this. For this example, we would use t equals 12 and either the value of t immediately less than that available in the table, so that would be t equals 9 and t equals 12, or t equals 12 and the value of t immediately greater than that that's available in the table, in this case t equals 15, or you can use the 2 values immediately on either side of t equals 12, so you could approximate it using t equals 9 and t equals 15. So if we do that, I'll use 9 and 15 in this case. W prime of 12 is just the value of this difference quotient. W of 15 minus W of 9 over 15 minus 9. From the table, W of 15 is 21, W of 9 is 24, and 15 minus 9 is 6. So we get negative 3/6, which is negative 1/2 degrees Celsius per day. In part B, we are asked to approximate the average temperature for for t greater than or equal to 0 and less than or equal to 15 using trapezoids of width 3. All right, so average value of a function, remember, is an integral, and we do have to multiply by the reciprocal of the length of the interval. Our interval is 15, so we're going to have to multiply by 1/15. So we have 1/15, and then if we use the trapezoids, we would have 1 of the very left endpoint, 2 of every endpoint in between until we get to the very right endpoint where we again would only have 1 of those. So that expression would look something like this, and then don't waste time doing this by hand. This is a calculator active question. As long as you have this expression written down, you've sufficiently communicated to the reader what you are asking your calculator to do. So go ahead and allow your calculator to do this for you. So enter this on a calculator, you get 25.1 degrees Celsius. All right, so that would be the average temperature of the water between t equals 0 and t equals 15 days using the information in the table and trapezoids of width 3. In part C, the model P of t equals 20 plus 10t e to the minus t over 3 is suggested as a possible model for this data, and then we are asked to find P prime of 12 and give its meaning. Well, first we can find P prime explicitly. That's just a little bit of calculus, derivative finding. We will need the product rule, 10t times e to the negative t over 3. That is going to require a product rule. So we would have 10 times e to the negative t over 3 minus 10t over 3, e to the minus t over 3. You could simplify that a bit if you wanted to. There's no need to do it here. And then if we want to evaluate p prime at 12, we just plug in 12 for t, and this would simplify a little bit. The t over 3 is going to be 4, so we have 10 e to the minus 4 minus 40 e to the minus 4, which is negative 30 e to the minus 4. And again, this is a calculator question. You could have a decimal for this. You could plug this into your calculator and get negative 0.549 degrees Celsius per day. But it's not required that you use your calculator to get a decimal here. You could have either of these two expressions, and that would be okay. Either 10 times e to the minus 4 minus 120 over 3, or maybe you write it as 40 e to the minus 4, or simplify it as negative 30 e to the minus 4. It's not required that you use your calculator, but you are allowed to. And then the meaning of this would be that, according to this model at least, the temperature of the water is decreasing at a rate of 0.549 degrees Celsius per day when T is equal to 12 days. Now, something you're going to want to watch out for here is when you have your rate of change, make sure that you account for the sign somehow, but make sure also that you do not double account for the sign. Since the sign of our rate of change is negative, we have two choices. We could say that the temperature of the water is increasing at a rate of negative 0.549 degrees Celsius per day, which doesn't sound like it makes a lot of sense, but it's technically accurate. It's increasing at a negative rate. Technically, it's decreasing, which would match. Or we can say that the temperature of the water is decreasing at a rate of positive 0.549 degrees Celsius per day. What we don't want to do is say something like it's decreasing at a rate of negative 0.549 degrees Celsius per day, because what we've actually done there is we've accounted for that negative sign twice, which means that the temperature of the water would actually be increasing, which it's definitely not doing. So definitely watch out for the signs that you use and the words that you use on questions like this. In Part D, we are asked what the average value of P of T is over the interval from 0 to 15. And again, average value is just an integral, right? So write the integral that you're going to find. Either one should be sufficient. But again, this is a calculator active question. There is no expectation that you will find this antiderivative by hand. So don't bother, right? We've set up our integral. The reader knows what calculus we're asking the calculator to do, so we plug that into a calculator. That definite integral comes out to about 25.757 degrees Celsius.